Okay guys, so what we're going to have a look here is a short video to allow you to, or to help you calculate the solubility of a solute in a solvent, usually a solid, ionic solid normally, in water. So the first thing we need to do here is make sure that we understand the actual definition of what solubility actually is. So just put it onto the screen here. So solubility is really the maximum mass of a solute which will dissolve in 100 grams of water at a given temperature. So note there, it is usually given to you per 100 grams. And if you look at our graph down below here, the y-axis is given as solubility, and it is indeed the units are grams, which is grams of the solute, or mass of the solute here, per 100 grams of the water. And that's the same as 100 cubic centimeters of water, because water has a density of 1 gram per cubic centimeter. So therefore, if you have, as I said there, a volume of 100 cubic centimeters with a density of 1 gram per cubic centimeter, well, that is the same as 100 cubic centimeters. So it's very important that you understand that, first of all. So the next thing we're going to have a look at interpreting these graphs and just seeing if we can work out a few very simple things about them before we start getting into the more complicated questions. So first of all, one examiner may ask you something very simple. For example, they may say, what is the solubility of sodium nitrate? This being sodium nitrate here. Okay, what is the solubility of sodium nitrate at 20 degrees? So all you would do there is you would go to your 20 degrees, you would draw a line on your graph up, you take that 20 degree line there, and you then draw a line across. Okay, and that gives you the solubility of sodium nitrate at 20 degrees. And your answer to that would be very simple, in that you would simply say that the solubility would be 90 grams of sodium nitrate if you want, or just 90 grams would probably do, per 100 grams of water. So in other words, if I have 100 grams of water and that is at 20 degrees, okay, at 20 degrees, I will be able to dissolve 90 grams of sodium nitrate in it. Okay, so this line is the line of saturation. Okay, so anything beyond that will not dissolve in the water. So for example, if for example I took it 20 degrees and I put 100 grams of the solute into the solvent, okay, it would not dissolve. Once you go above this line anywhere, that solid will no longer dissolve. So if you think about it, if I put 100 grams in at 20 degrees, what would happen to the extra 10 grams? Well, very simply, if you had your beaker there and you had your water in it and you had your solid dissolved in it like so, what would happen is the 10 grams of it would simply settle to the bottom and crystallize and wouldn't dissolve, because once the solution becomes saturated, in this instance at 20 degrees, okay, you can no longer dissolve any. So how might you go about getting that to dissolve? Well, if we had 100 grams and we wanted it to be saturated, what we would have to do is, if we went across from our 100 gram line across to here, okay, well there you go, that's the point at which, sorry, when we go down from there then, in a straight line, so that's roughly, I would say, about 37 degrees. So if I wanted to get 100 grams of this substance to dissolve, I would have to heat the 100 grams of water up to about 37 degrees Celsius, and at 37 degrees Celsius all of that 100 grams of sodium nitrate would of course dissolve. So what else might the examiner ask you? Well, they may ask you then, okay, well, you have a saturated solution. Okay, we'll just call it a SAT solution to save time here. Saturated solution of sodium nitrate. Okay, and let's say that saturated solution is at 40 degrees Celsius. And let's say the examiner then says, okay, well, we take that saturated solution and we cool it, and we're going to cool it down to 10 degrees Celsius. So what mass in grams of sodium nitrate would you have sitting crystallized out at the bottom of your beaker. Well, let's have a look at exactly that. So the first thing that we would do is we would find out what is the solubility of the sodium nitrate here at 40 degrees first of all, and what is the solubility of the sodium nitrate here at 10 degrees. So again, if we take our ruler and we go up to 40 degrees here, okay, so there we go, and we take our ruler again, we go across. Okay, you'll be more accurate than I am here. And if we have a look at the solubility therefore at 40 degrees, it's about, I would say, it's about 105 grams there. And if we do exactly the same, then we go down and we have a look at our solubility, but this time we're going at 10 degrees. Okay, and from the 10 degrees then we go across, and that's, I would say, it's about 80 degrees there. Sorry, 80 grams. So at 10 degrees we have a solubility at about 80 grams. So at 40 degrees I can dissolve a maximum of 105 grams. At 10 degrees I can only dissolve 80 grams. So therefore, if I take a solution which is saturated at 40 degrees and I cool it right away down to 10 degrees, therefore I must have 25 grams of the solid which crystallizes out. And what that simply means is that if I have my solution in water, I will get very simply a solid of 25 grams, sorry, lying at the bottom of that container. Okay, so let's have a look at another type of a question that the examiner may ask us here. So this time we're going to have a look. We'll have a look at again, we'll stick with our sodium nitrate because you know the trend in all the graphs, apart from this selenium sulfite down at the bottom, which is one that you're unlikely to get asked at GCSE level. If we have a look down here, we take sodium nitrate, and let's say the examiner says this time, okay, you have a 25 grams of water, okay, and you have a saturated solution. Okay, saturated solution of, again, we'll stick with our sodium nitrate, and we'll say that that's at 30 degrees Celsius. And then if we cool that, okay, and we're going to cool it down to, we'll cool it down again to 10 degrees Celsius. So the question therefore is, what mass, okay, so what grams of the sodium nitrate, the NaNO3, okay, what mass of it will, that should be will crystallize out. In other words, what mass will lie at the bottom. Now the key thing here is that suddenly instead of having 100 grams of water, we're only got 25 grams of water to dissolve it in. So the first thing that we do is we go and we find out the solubility at 30 degrees C. Okay, so we take our 30 degrees C line, we bring it up, and then we bring it across to there, and I suppose that's probably about 98, I would say. So at 30 degrees Celsius we get about 98 grams dissolving. Now that is 98 grams per 100 grams of water, so we need to be careful because here we only have 25 grams of water. So the question is, okay, well, how do we work out if we had 98 grams dissolving in 100 grams, how much would dissolve in 25 grams? Well, in 25 grams you're only going to have a quarter of the volume, so therefore you're going to have exactly the same. You're only going to get a quarter of the 98 that would dissolve, and that is 24.5 grams would dissolve in 25 grams of the water. Okay, so next question then is if we have 10 degrees Celsius. So at 10 degrees Celsius, so we'll do exactly the same thing. We'll take our 10 line, we'll go up, and we will take it across then, so that's a at 10 degrees Celsius we would have 80. So at 10 degrees Celsius we would be able to dissolve, as we found in our last slide, 80 grams, but that is, remember yet again, per 100 grams of water. Now if we divide that by 4, okay, to bring that down to per 25 grams of water, that means that we would have 20 grams of sodium nitrate per 25 grams of water. So when we reduce the volume of water at 40 degrees we can dissolve 24.5, and at 10 degrees we can only dissolve that. So in the bottom of our beaker, if we cool that down, we would have only 4.5 grams of the solid. So that's how we apply or adapt our question if we're giving a reduced volume of water. Now, what about then if we're given a larger volume of water? So let's take this time, we'll take something different. We'll go to potassium nitrate. Okay, so let's say we've potassium nitrate at, so we've got potassium nitrate at 50 degrees Celsius. Okay, we have 50 degrees Celsius, and we have, let's say, 250 grams of water this time. So we've increased the amount of water, and we cool that down from 50 degrees Celsius. We're going to cool that down to 20 degrees Celsius. Okay, and again it's going to be dissolved in 250 grams of water, as opposed to our graph, which again shows everything per 100 grams of the water. So let's go and do our lines again and see how we go. So we're looking at potassium nitrate this time. We'll just write that up there just to remind us. So it's a different line. It's KNO3, which is our potassium nitrate. So let's look at our 50 grams here. If we go up, okay, and we'll take that line from 50 and we'll go across. So at 50 we will dissolve 80 grams of the solid. So 80 grams of the solid, okay, at 50 degrees Celsius. But remember that that is in 100 grams of water. So how do we work out how much we would have in 250 grams of water? Well, we simply multiply the 80 by 2.5. Okay, because 2.5 100s is obviously 250. So that means that we would have 200 grams, okay, at 50 degrees Celsius. In this time, remember, it's 250 grams of water. So we've established what mass of our potassium nitrate will dissolve at 50 degrees Celsius if we have this time 250 grams of water. So let's go down to our 20 degrees Celsius line and we'll go up to our potassium nitrate. Make sure we get the right line because there's a lot of lines here. Okay, so there we go. We go up and we go across, and that works out at 30. So what can we establish from that? Well, we can establish that 30 grams of the potassium nitrate will dissolve at 20 degrees Celsius, and that is remember 100 grams of water. Okay, and if we take that and we multiply it by 2.5 to scale it up to 250 grams of water, we will find that in 250 grams of water we should be able to dissolve at the same temperature 75 grams of KNO3 potassium nitrate at 20 degrees Celsius, and that is in 250 grams, which is what we were after. So therefore we've got originally up here 200 grams at 50 degrees Celsius, and when we cool it away down to 20 degrees Celsius we can only dissolve 75 grams at 20 degrees Celsius. So that means crystallized out at the bottom of our beaker we will have 125 grams of our potassium nitrate solid, and it'll just sit there as a white crystals. Okay, so we've done one where we just had a normal calculation as the examiner might ask us. Okay, we have done one where we've scaled the volumes down to 25 grams. We've done one where we've scaled the volumes up to 250 grams. The next thing that they might ask you is perhaps something like at what temperature is the solubility of potassium chlorate? Okay, and I'll identify potassium chlorate for you. At what temperature is potassium chlorate and selenium sulfite the same? Well, or the solubility of them the same, I should say. Well, the solubility of both of them, oops, sorry about my unsteady hand there, is the same at this point here. It's both of the solubilities. I should use the little arrow. Okay, so the solubility of both of them there is at about 7 or 8 grams per 100 grams. Okay, and that is at roughly, okay, we'll say 19 to 20 degrees Celsius. So the solubility of both of those is exactly the same at 19 to 20 degrees Celsius. Okay, which they may ask you which of the compounds is the most soluble at, let's say, for example, 20 degrees Celsius. Well, at 20 degrees Celsius, if we go up, the most soluble by far, we're just going up that line that I'm about to put on this screen now. We're going up there, up that line. Well, the one that quite clearly is the most soluble is the potassium nitrate at 20 degrees Celsius. Okay, which one is least soluble, they may ask you at that temperature. Well, let's not go that temperature. Let's go 10 degrees Celsius for the least soluble. Well, the least soluble we'll do our line at 10 degrees Celsius. So we're there. The least soluble at 10 degrees Celsius is this one here, which is the potassium chlorate, KClO3. So it's the least soluble at 10 degrees Celsius. They may ask you which solid is least affected by solubility, is least affected by change in temperature. Well, that's the sodium chloride line here, which really doesn't change very much at all the whole way through from 0 degrees right up to over 100 degrees. It only increases by a couple of grams per 100 grams of the water. They may ask you which solid has its own unique solubility properties, and that would be the selenium sulfite, because as you increase temperature, rather bizarrely, its solubility actually decreases. And generally we would think of solids as increasing in their solubility as the temperature increases, because there's more energy available to pull the ions apart from each other. Okay guys, that's pretty much it in terms of doing some calculations to work out the solubility of solids. I hope that little tutorial helps you.